So, hello guys. Welcome to my class. Okay? So, we will proceed to another problem, which is shear and moment functions. In my previous video, it's about internal loadings at specified point, meaning we want to determine the normal shear and bending moment at a certain point. Okay? So, in here, our problem will be about shear and moment functions. Okay. So, let's solve this problem. Determine the shear and moment in the beam shown in the figure as a function of x. Okay, so we want to determine the shear and moment in terms of x, and what will be the significance of this one. If you have these functions, you can now determine the shear and moment at any specified point. Okay, so this is important, and this is one way on how to check whether you are in the correct track in determining the shear and moment values, of course, and for the shear and moment diagram. So the beam will be it's a pin, and you have here a roller with a triangular trapezoidal loading. Is it clear? Yeah. So here it's 9 meters, and this is 10 kilonewton per meter, and you have here 30 kilonewton per meter. Let's say this is point A and this is point B. So in determining the shear and moment function as a function of x, the shear and moment as a function of x, you should check whether the loads is applied on a specified length or not. Okay, because this will be your basis whether you will have one or two more functions. It depends on the loads applied on the structure. Okay, so here the loadings applied at point A and B, meaning we will have only one functions. Okay, so to do that, to determine the shear and moment as a function of x, we need to determine first the reactions. Okay, so for the reactions, okay, we can divide this into two. So if this is 10, this is also this is 20. Okay, so we have here, let's say this is AY, AX, this is BY, and of course the load of this one is located at the middle. It will be 10 times 9, located at 9 half, and the other loading will be the triangular loading of this one. Okay, it will be 1 half, 9 times 20, which is located at 1/3 of 9. Okay? So this is 90 kilonewton. And this is 90 kilonewton. So we can now determine the value of AX, AY, and BY by using the equilibrium equation. Summation force along X, 0, plus AX is there any horizontal reactions here? None. So this is 0. Summation forces along Y is equal to 0, upward, positive. Okay? Of course, using this summation forces along Y, we cannot solve anything. Because using this one, you have two unknowns AY and BY. Okay? So we can have here summation moment. We will use this later. Moment at, let's say, at A plus, okay, is equal to 0. This one and this one is only my assumptions. These are my assumptions. So BY times 9 minus 90 times 4.5 minus 90 times, this is 6 meters. 6 meters, 0. BY times 9 minus 90 times 4.5 plus 90 times 6. 945 is equal to 0. So BY is 945 over 9 kilonewton, which is equal to 105 kilonewton. So if this is positive, meaning our assumptions are correct, BY is really upward. Okay? So here, summation force along Y, AY plus BY minus 90 is equal to 0. AY is 75 kilonewtons. Can you see it? Yeah. So we are okay. We have already the reactions of AY, AX, and BY. So now, a free body diagram of the cut section can be done. Okay? So we can have here, let's say, value of X. Okay? So what will happen is that this is 75 kilonewtons and this is said to be X. Okay, what else? We can assume that you have your shear B and you have moment M. Okay, so this is 10, right? This is 10, this is also 10, and let's say this is Y. Okay, so now to determine the value of Y, we can use the original one. $29. This is Y and this is X. So y is to x is equal to 20 over 9. So y is equal to what? 20x over 9. Okay, so you have here 20x over 9. So to get the equivalent load, this will become 10x, and this will become 1/2 of 20x over 9 times x. Okay? So, we can now determine the shear. Okay, summation forces along y is equal to 0, upward plus, so negative 10x minus 1/2 20x over 9 times x plus 75 minus b is equal to 0. So 10x minus 10 over 9x squared, which is 1.11x squared plus 75 minus b is equal to 0. So shear is 75 minus 10x minus 1.11x squared. So this is the shear as a function of x. Okay? Can you see it? Yeah. How about for moment? Summation moment at, let's say this is point S. S is equal to 0. You can assume any direction, let's say positive, counterclockwise. So moment minus 75 times x plus 10x times x over 2 plus 1.11 x squared multiplied by, what is this distance? This is 1/3 of x times 1/3 of x is equal to 0. So m minus 75 x plus 5x squared plus 1.11 over 3 is 0.37 x cube is equal to 0. Now, the moment will be 75x minus 5x squared minus 0.37 x cube. So this is now the moment equations. Okay? So this is how, or this is the procedures on how to determine the shear and moment as a function of x. Again, you should always take a look at the loadings, whether the loading is continuous or not. If it is continuous from point to point, that is already one function. Okay? Else, it will be 2 or more depending on the loadings. So that's it. We will have another examples for shear and moment diagram of a frame. Thank you.